So for this part of the vectors, right, we are um, trying to understand the definition of a parallel vectors. So this one is one of the critical concepts that is always being tested. So when we say parallel vectors, okay, we got some definition. So the definition of a parallel vector. So when we say two vectors are parallel, then this will be the formula. So there will be a constant to account for the parallel vector. So why is there a constant to account for parallel vector? Okay, so think about it in this way. When we say parallel vectors, they only mean same direction. So that is quite direct, right? These two vectors are parallel, but they may not be the same length. So when vectors are parallel, they are only having same direction. The length may not be the same. That's why there is a constant. So for example, maybe I roughly can guess A is like half of B. So they are parallel, but their length are not the same. So the constant is to account for the difference in length. Okay, so that is one of the concepts that you must have. So if you don't put the constant, that means you are trying to express the idea of equal vectors. So later on, you will learn another concept for equal vectors. Equal vectors will be the part where they got same direction and same length. But right now in parallel vectors, we only got same direction. And because their length is different, you should always have a constant to relate the two vectors, something like this. So the constant is to account for the difference in length. So that is the basic concept first. Okay, so I'm going to use this basic concept to show you example 2A. Okay, then I will talk about a little bit more because this is the concept that will lead you to explain. So one of the explanation question in vectors will be based on this concept. Okay, so based on this idea, understand that parallel vectors means the direction is the same, but the length is different. So because the length is different, there's a constant to account for it. So for example 2A, if you read the question, A is parallel to B. So this is A and then this is B. So because they are parallel, okay, I know that A should be equal to KB. So the constant is to adjust for the difference in length. Okay, so if you look carefully, A is 6 minus 8. And then B is 15H. So do you realize that it happens that vector B also got an unknown? So please be mindful of the unknown. We try not to use the same alphabet. So for example here, if let's say this question is a K. If this question is already a K, I wouldn't use a K here. I will use something like H here. I want the constant to be different alphabet. Okay, so don't go and put the same alphabet. So you need to take note. Okay, so in this question, right, so the given one is H. So it will be okay for me to put the constant that accounts for parallel vector. So because of the parallel vector, I apply this idea. But the question is only asking for H. So what are you going to do? So you do a bit like your matrices. You multiply, and then you do a comparison. You do a top equal to top comparison. Then you do a bottom comparison. So the bottom should be the same, the top should be the same. Okay, then you do a little bit like a simultaneous equation. So you answer the question. While you answer the question, you also find the K, which essentially is part of the working. Okay, so when vectors are parallel, you need to have a constant to account for the difference in length. But that's because they need not share the same length. They just need to have the same direction. Okay, the next one is the more critical one. So in general, in a opposite manner, if let's say we got something like this, if you see this expression, if you see two vectors being related by a constant, it tells you two things. The first thing it tells you is the vectors are parallel. And it also tells you the ratio of the magnitude is how many times. Okay, so just like the half here. So when it is half, right, I know that A is 1 unit, B is 2 unit. So something like this is 1 unit and then this is 2 unit. Okay, so if you have two vectors that's related by a constant, it is an indication that the two vectors are parallel and the magnitude is in a certain unit, in a certain ratio. So this will be a common question that they keep asking you, especially in E-Math paper 1. Okay, so like I will be showing you this through example 2B. That's why I put an asterisk on example 2B. So let's try to answer part A first. Okay, part A is just asking me to do a column vector, which is very much like your matrices. So be very patient about it. Be very careful about it. 8 plus Q, 3Q. 8 plus 3Q. So that's 11. And then there's also 11. So we got 4P minus R. Okay, please indicate with the tail. So usually for a start, most of you will not have the habit of doing that. So do like your matrices. Okay, then you do your subtraction. Okay, so if you look carefully, the numbers are quite easy to derive, but this is the challenging part. I need to write out two facts about the two vectors. So I can only be writing the two facts if the two vectors are related by a constant. So how am I going to be doing it? Okay, so I'm going to show you a trick that I will do. Sometimes it's very direct. Sometimes it's not direct. So this is a case that is not direct. So I'm going to be doing this. So this is 11, 11. The common factor is 11. So you take a common factor out. So for 4P minus R, the common factor is a 3. And then you end up with a column vector 1, 1. So I'm going to target the 1, 1. So if I target the 1, 1, it means that it will be 1 over 11 P plus 3Q. So I kind of divide the 11 over. So here I'm going to divide the 3 over as well. So I will get 1/3. I will get 1/3. So once I can do that, that means, right, these two are the same. So therefore, 1 over 11 P plus 3Q is the same as 1/3 4P minus R. you multiply 11 on both sides. When you multiply 11 on both sides, you will get something like this. So the two vectors are right now related by a constant. So these two vectors are related by a constant k. So what will be the two facts? So then you can start writing. So fact number 1, that means right, P plus 3Q is parallel to 4P minus R. And it also tells me about the magnitude. The magnitude of P plus 3Q is 11 over 3 of the magnitude of 4P minus R. So in a way, I know that this one is the longer one. So this part is 11 units. This part is 3 units. So they are different in length, doesn't matter, but they have the same direction. The direction is the 1, 1 direction. So this one is the direction that they are following. It's just that they are following it in different length. Okay, so sometimes this one is the very indirect one. Sometimes you can tell from the vectors that they are like how many times of each other. So this one is very important. In your E-Math paper 1, they will be asking you for 2 facts, and each fact will be like 1 mark. Okay, so that's one of the important concepts in vectors, parallel vectors.